This video is on the reducing ability of the halogens. So our aims for this video are to know and explain the trend in the reducing ability of halogens, know the products of the reactions of the halide salts with concentrated sulfuric acid, and if you know these reactions, then it's easier to do the third aim, which is to write half equations and full equations for the reactions of the halide salts with concentrated sulfuric acid. Halide salts are basically halogen ions, so chloride ions, fluoride ions, bromide ions, combined with the alkali metal ions. So potassium chloride is a halide salt, potassium fluoride or sodium fluoride is a halide salt. So in order to know and therefore explain the trend in the reducing ability of halogens, we've got to look at what products are made when we react the halide ions with concentrated sulfuric acid. And what the reducing ability means is basically how well the halide ions reduce the sulfur in the sulfuric acid. So if we can look at the oxidation states of the products made, we can see how well the sulfur is reduced by how much the oxidation state was reduced, basically. So this first video I'm going to show you is a reaction between sodium chloride and sulfuric acid. And remember, it's basically the chloride ions in the sodium chloride that's going to be reacting with the sulfuric acid. So if you watch the video, I'll try and explain what the products are that are made. So here we are. I'm putting concentrated sulfuric acid, which is this in my right hand, into a conical flask which already contains the sodium chloride. And if you watch, you can see straight away that steamy white fumes are being made. You can see the mixture is bubbling. And this is litmus paper I'm putting into the mouth of the flask. You can see the litmus paper is going from a blue colour, and if you watch it goes to a red colour, if you can see that close enough. And so what that means is that these steamy white fumes that are being made is an acidic gas. And what that acidic gas is hydrogen chloride gas. So what is made from this reaction is hydrogen chloride and sodium hydrogen sulfate. If we look at the oxidation states of the chloride and the sulfur in these products and the reactants, we can see that the chloride ions in sodium chloride has an oxidation state of -1, and the chloride ions in hydrogen chloride also has an oxidation state of -1. So the chloride ions haven't changed oxidation states. Again, if we look at the oxidation state of sulfur in the sulfuric acid up here, sulfur is +6 if you work out the oxidation state. If you don't know how to work out oxidation states, then have a look at my oxidation states video, and that will explain how to do that. And if you look at sulfur in the sodium hydrogen sulfate, that also has an oxidation state of +6. So this is not a redox reaction. All this is a displacement reaction. So chloride ions do not reduce the sulfur in the sulfuric acid. And that's important we look at the trend and therefore explain the trend later. This next video is going to be the reaction between sodium bromide and sulfuric acid. So we just watch this, I'll try and explain what's happening. So, that's me just pouring in some sodium bromide, that's this powder. Sorry, this powder here, I'm pouring in. And we're going to be adding this concentrated sulfuric acid to this.
So all that happened there...
Does it get any more exciting than that?
Yes, all that happened there was hydrogen chloride gas was made, okay?
I apologise, I'm taking my time.
So now we're going to go on to sodium bromide. Okay, I want you to notice some colour changes.
Okay, so we add these two things together.
Okay.
Watch what happens first. At first, a similar sort of thing happens to what happened with the sodium chloride and sulfuric acid. You can see that a steamy white gas is being made, and that this time is hydrogen bromide. So hydrogen bromide and sodium hydrogen sulfate is being made first. But if you carry on watching, you can see that now the mixture is turning an orangey colour, and that orange colour is bromine being formed. So the other thing we make is bromine, and you can't see it here, but that gas that's being given off now is sulfur dioxide. So we make bromine and sulfur dioxide. So there's two reactions happening here. These are the products of the first reaction, and then the bromide ions react further to make bromine and sulfur dioxide. And you can see that that's becoming a really orange colour now. So if we look at the oxidation states now, we've gone from -1 and +6 in the reactants. This initial first reaction that happens, which happens every time, is a displacement reaction, and that's as far as the chloride ions got, but again we've got -1 and +6. That's not a redox reaction. If we look at the second reaction, the oxidation state of bromine is 0, and the oxidation state of sulfur here is +4. So we can see the sulfur has been reduced from +6 to +4, and it's important you remember those oxidation states for later on. This final reaction I'm going to show you is the reaction between sodium iodide and sulfuric acid. So let's watch this.
Last one. So this one.
So the first reaction that's going to happen here, so you can see I'm pouring in some sodium iodide into that conical flask. Again, I'm going to pour this concentrated sulfuric acid in. The first reaction again that's going to happen is that sodium iodide and sulfuric acid react to make hydrogen iodide plus sodium hydrogen sulfate. But if we carry on watching, we can see that the mixture is now turning a black colour. You can also see, if you watch carefully,
Liam Perrin's sauce.
Okay.
You can also see a yellow colour being made further up the flask. Now that yellow colour
I've got a cold, I won't be able to.
Can anyone smell anything?
is sulphur.
I can.
The black colour is iodine. You also make sulphur dioxide, like you did before. And finally,
What did it smell like?
if you smell the products being made, you'll be able to smell an eggy smell, and that eggy smell is H2S, hydrogen sulfide. So you can see here we've got a yellow colour, which is sulphur, a black colour, which is iodine, I2, and then the gas that's giving off is H2S. And you'll also make SO2. If we look at the oxidation states of these products, again we're starting with -1 in the iodide ions and starting with +6 the sulphur. Again we've got -1 and +6 in the first reaction, which again is the displacement reaction that always happens, but in the final products here we've got iodine, which is 0, sulphur, which is 0, sulphur dioxide where the sulphur is +4, and hydrogen sulfide where the sulphur is -2. So you can see here the sulphur is being reduced even further from +6 to -2, and it goes all the way through +6 to +4 to 0 to -2. And so the iodide ions actually reduce the sulphur even more than the bromide ions did earlier. So if we just go through those three reactions again, we've got chloride ions, number 1, which made hydrogen chloride and sodium hydrogen sulfate, and that was not a redox reaction. The sulfur still had an oxidation state of +6. The second reaction made bromine and SO2, where the sulfur there has an oxidation state of +4, and the third reaction made iodine, and the most reduced product was H2S, which had an oxidation state of -2, the sulfur there. And so you can see that as you go down the group of halogens, they get better at reducing. So reducing ability of the halogens increase down the group. And the reason for this is basically due to their electron structure. So if you think about it, if the halogens are reducing the other thing, they are the reducing agents, so they're being oxidized themselves. So these, the halogens are losing electrons if they're being oxidized themselves. And they get better, or it becomes easier to lose the electrons as you go down the group, because the electron that's being lost is getting further and further away from the nucleus. There are more electron shells, and so therefore there is more electron shielding. So that outer electron becomes easier to remove, and therefore the halide ion becomes easier to oxidize. And we're going to have a look at a question at the end which asks us to explain that, and I'll show you how you put that down in an exam question a bit later. So as I said before, you have to know the products of the reactions between the halide salts with concentrated sulfuric acid. Some of those products are going to be reduction products, and some of those products are going to be oxidation products, some of those products are going to be neither. And so the reduction products I'm going to write in red, and the oxidation products I'm going to write in blue. The oxidation products come from the halide ion themselves, and the reduction products come from the sulfuric acid. The first reaction between sodium chloride and concentrated sulfuric acid didn't have a redox reaction, and what you made there was hydrogen chloride gas, and you made sodium hydrogen sulfate. Now this sodium here comes from the sodium in sodium chloride, and so if it was potassium chloride instead for the halide salt, this would be potassium hydrogen sulfate, and it's important you're clear about that. So there is no reduction product, no oxidation product. This is just a displacement reaction, if you like. The reaction between sodium bromide and concentrated sulfuric acid yields still the displacement reaction, so you'll get hydrogen bromide and sodium hydrogen sulfate, but you'll also get a reduction product and an oxidation product. The reduction product is from the sulfuric acid, and that is SO2, and that's all you make, and you also make bromine as the oxidation product, Br2. And then finally, for the sodium iodide, the oxidation product you make iodine, I2, and the reduction product you make SO2, but you also make sulfur, and you make H2S. And in an exam they may ask you for a specific one of those. So sulfur is a yellow solid, so they may say give the solid reduction product of the reaction between sodium iodide and sulfuric acid. You've got to make sure you know. This sulfur dioxide is an acidic gas. They may describe that in that way. And H2S is also a gas. It's poisonous. So they could describe it in that way. So you need to know these products here, because the exam might require you to. So finally, we need to be able to write half equations and full equations for these reactions. So the first reaction between chloride ions and concentrated sulfuric acid, as I said, was just a displacement reaction. And so you just get NaCl plus H2SO4, and that makes HCl and NaHSO4. So you've got hydrogen chloride and sodium hydrogen sulfate. And as I said, that's not a redox reaction, so you can't write two half equations for that. The second reaction is between sodium bromide and sulfuric acid, and here you can write two half equations, and you ignore the sodium in this case, because the sodium is not doing anything in the redox reaction. It's the bromide ions sulfuric acid that is. So you've got bromide ions, and they're turning into bromine. I'll just scribble this out now so you can ignore that. That's nothing to do with this next one. And then you've also got sulfuric acid going to make SO2. And now you've got to balance these two half equations like I've shown you in the videos before, and if you don't know how to do that, then make sure you watch the videos. I'm just going to do it quickly for these. So for the bromide ions to the bromine, first balance the bromine, so you've got to need two bromide ions making this Br2, and then balance the charges by adding electrons. And the second one, first you balance the sulfurs, they're already balanced, then balance the oxygens by adding water, then balance the hydrogen ions by adding, the hydrogen by adding hydrogen ions, and then balance the charges by adding electrons. You need two on this left-hand side. Now you can see the electrons already balanced in the two equations. There's two in each one. So all you do now is add them together to make the full equation. So you've got 2Br minus plus 2H plus H2SO4 goes to make SO2 plus 2H2O plus Br2. So as I say, you don't have to remember this equation. If you can just remember what is made and what they're made from and how to balance the half equations, how to combine them, this equation will come naturally. You don't have to remember the equation off by heart. The next one is the iodide ions, and I'm just going to show you the iodide ions reducing the sulfuric acid to the most. So to make hydrogen sulfide, that's the biggest reduction of all of them. So again, you've got your two half equations. So you've got I minus iodide ions turning into I2, and you've got sulfuric acid turning into H2S. Now they could ask you to do it for sulfur or SO2, and you do it slightly differently because it would be different balancing, but I'm just going to show you this one. So the top one, you've got 2I minus and you've got 2 electrons on the other side. That's now balanced. On the second one, the sulfur's already balanced, then balance the oxygens with water, then balance the hydrogen with hydrogen ions. So you've got 8, 10 on this side, and you've got 2 on this side already, so you need 8 H plus on this side, and then balance the charges of electrons, you also need 8E minus. Now this time the electrons don't cancel, so we need to multiply this top equation up by 4 so that you've got 8 electrons in this top equation. So now you're going to have 8 electrons, 4I2 and 8I minus, and now we just combine these two things to get the full equation, and that will be 8I minus plus 8H plus H2SO4 goes to make 4I2 plus H2S plus 4H2O. So let's have a look at some past exam questions on this. So this first question is your half equations question. So the concentrated sulfuric acid is reduced when it reacts with solid potassium bromide. Concentrated sulfuric acid is not reduced when it reacts with solid potassium chloride. So in here it wants you to write the two half equations for this full equation here. So they're actually helping you quite a lot here because they're giving you the full equation. So it's showing you what's being made from the different reactants and products. So the first half equation, you've got Br minus turning into Br2. In the second half equation, you've got H2SO4 turning into SO2. And now you've just got to balance them. Now you could just copy from the equation above, but I'd rather you balanced it and then checked it was right from the equation above. So you've got 2Br minus goes to Br2 plus 2 electrons. And then the second one, you've got to balance sulfurs first, that's already balanced. Then balance the oxygens by adding water. Then balance the hydrogens by adding H+, and then balance the charges by adding electrons. So there's your two half equations, which would combine to make this full equation if you added them together. The next question says, write an equation for reaction of solid potassium chloride with concentrated sulfuric acid. So you know that you got potassium chloride plus sulfuric acid. Notice they don't give you the formula of potassium chloride. You have to remember that it's only one chloride ion with the potassium. And that will make, as we've discussed before, hydrogen chloride, and the other product will be this time potassium hydrogen sulfate. Because remember I said that what this product is will depend on what the alkali metal is that is combined with the halide ion. And in this case it's potassium, so instead of sodium hydrogen sulfate we make potassium hydrogen sulfate. And again that is the reaction there. And then it asks you to explain why the chloride ions are weaker reducing agents than the bromide ions. So to get the 2 marks here, remember, if something is a reducing agent, then it's being oxidised itself. So you can say that the bromide ions oxidise more easily. Oh, sorry. I think I'd rather you said that they are oxidised more easily. So the bromide ions are oxidised more easily, because remember that's what's happening to them when they're reducing agents, which means they lose electrons more easily. Because it has more shells of electrons and therefore more electron shielding. You could say instead that the outer electron is lost more easily due to the fact it has more shells of electrons and therefore more electron shielding. This first sentence here, bromide ions are oxidised more easily, isn't actually required. I'm just putting that in there to remind you that that's why we're talking about losing electrons, because the bromide ions are oxidised if they are reducing agents. There's next question that I'm going to show you requires you to know a little bit about the reactions. So first question says, identify a sodium halide that does not undergo a redox reaction when added as a solid to a concentrated sulfuric acid. So a sodium halide means you've got to have sodium with it. So it either can be sodium chloride, remember that doesn't reduce the sulfuric acid, just as a displacement reaction, or you could have sodium fluoride, because if chloride ions don't reduce the sulfuric acid, then because the fluorine is above chlorine in the periodic table, the trend suggests that fluoride ions also will not reduce the sulfuric acid. Then it says, give the formula of the substance responsible for the orange colour when chlorine gas is bubbled through an aqueous solution of sodium bromide. Now that isn't actually a question that has been answered in this video, and so I suggest you look at the oxidising ability of the halogens video to answer that question. Finally, we've got solid sodium iodide undergoes a redox reaction with concentrated sulfuric acid. Give the formula for each of the following in this reaction. Now notice it says the formula. Now you can't put the name. You've got to write the chemical formula with the symbols. So formula of the solid reduction product. Remember I said that the solid reduction product is sulfur when you have iodide ions react to sulfuric acid, because H2S is a gas and SO2 is a gas, so sulfur is the solid reduction product. And the oxidation product is from the iodide ions, and they make iodine. And it's important that you write iodine as I2, because that's how iodine exists. The sulfur you could write as S8 if you wanted to, but S by itself is also fine. Now if you have any further questions on this video, then please make sure you email me, and I'll get back to you as soon as possible.